proof, of course. We'll apply this condition also, then I'll prove it that it is correct. At least you should get convinced that these formulas are correct. Formula derivation is a little bit advanced, but instead of going with that, I'll prove. So let us take. So the question is right on. Check whether the following forces are conservative or not. Check whether the following forces are conservative or not. Coming. Check whether the following forces are conservative or not. I'll keep it simple. I'll take it like this. Okay. So F is equal to X I cap plus Y J cap. We have to check it. Okay. So first method, we'll apply this. What we have. So it's a very simple case because you have only X and Y component. Coefficient of I cap is the X component and coefficient of J cap is the Y component. So take the X component. So this is X component, F of X, Fx, not F of X, Fx. Similarly, this is Fy. Okay. So therefore, dou of F of X with respect to Y. So when you partially differentiate, it will be 0. Similarly, it will be 0 and F of Y with respect to X. So when you partially differentiate with respect to X, it is 0. Is this okay? Derivative of X with respect to Y is 0, no? Because when you are differentiating with respect to Y, only Y is the variable, X is a constant. Similarly, when you are differentiating with respect to X, X is the only variable, Y is a constant. So it is true, it is correct. So actually our formula says that it is a conservative fit. We'll prove it. We'll take any two paths, we'll calculate work done by two different paths, and if it is same, that means conservative. Isn't it? So let us take like this A comma A. So let us say that we start from origin. We start from origin. We take the body along the path OMP and next along the path ONP. These are two different paths. We have chosen axis because work done will be easier to calculate. We can choose any two different paths. But if we take any other path, it will be slightly more cumbersome, that is tedious, it will become tedious. So we have chosen path along that. So let us first find the work done along the path OMP. OMP. So work done is a scalar quantity. You can calculate the work done by resolving this into individual paths. So OM is one path and MP is another path. So as you take the body along the x-axis, y coordinate is 0. Isn't it? So for this, when y coordinate is 0, you have only xi cap. Isn't it? dx integrated with limit 0 to a, because we brought from here to here. Work done is force into displacement. Force is only x because y is 0 here. Y is 0 here. You have only x I cap and displacement is dx. So both are in the same direction. So cos 0 is 1. Now when it is here already x is fixed. How much is x? X is a. Only y is changing. So x is fixed. X is fixed. Only y is changing. Force into displacement vector is dx I cap plus dy j cap. Okay, this is the elementary displacement vector. Integrating between limits, of course, y will be the, you integrate this. This will be a square by 2. I have put the limits also. So this will be a dx plus y dy. X varies from 0 to a to a. There is no change in x, but y varies from 0 to a. Dx did not change, no? So this will also be a square by 2. So final answer is a square. This is a square by 2, this is a square by 2, this is 0, 0. X did not change, x remains same from M to P. Then let us calculate the via the path this. Work done via the path O N P. So work done via the path O N plus work done via the path N P. So for O N you can see x coordinate is 0. For any point on the y axis x coordinate is 0. So if x is 0, this will be 0, you have only y. So y, and you are moving along y axis, so integral dy 0 to a. And for NP, here y is constant. And moreover, you are moving along x axis. You have to take only this part. You don't have to take this part because this is in the y direction. Work done as you move along x axis, y direction will be 0. Isn't it? Are you understanding? You have to take only this part because you see this was 0, no? I am talking of N to P. You don't have to consider this because this is the force in the y component. Displacement is along x component. Force work done will be 0, so don't consider. Only consider this. We are moving along x axis, so integral x dx x varies from 0 to a. So same thing we have a square by 2 plus a square by 2. So it is conservative because we are getting the same. Is it okay? Now you solve. I am giving this question. Suppose it is taken via the path OP, direct straight line path. Then you calculate work done. It should be a square, no? Do it. Calculate the work done if the particle is taken along the straight line OP. Show that it is also a square because it has to be a square. As long as you start from O and reach P, whether you go this way, anyway, it should be a square because after all it is under. Calculate and show that it is a square. Do it. Work done is shifting the particle from O to P along the straight line joining O and P. Close this.